In this video, we are going to talk about how to calculate the theoretical and percent yield of a compound. So the first thing we need to do is write a balanced chemical equation. So we have C3H8, which stands for propane, and it's burned in air, so it's going to react with oxygen gas, and it's going to produce carbon dioxide, and the other product is water. The reason being, it's a combustion reaction. You always get CO2 and water as products. So now we got to balance it. Whenever you want to balance a combustion reaction, you want to balance the number of carbon atoms first. We have 3 carbons on the left, so we're going to put in 3 in front of CO2. Next, we're going to balance the hydrogen atoms. So we have 8 on the left, 2 on the right. We know 4 times 2 is 8. And then finally, we need to balance the oxygen atoms. We have 6 oxygen atoms in the 3 CO2 molecules, 4 on the right from H2O, that's 10. 10 divided by 2 is 5, so we need to put a 5 in front of O2. So now the reaction is balanced. Okay, let's make a list of what we know. We have 30 grams of propane. Now, it's burned in air, so we can assume that we have an excess amount of oxygen. Whenever you have two reactants, you need to identify what's the limiting reactant and what's the excess reactant. You always want to use the limiting reactant to calculate your theoretical and percent yield, never the excess reactant. Now, the equation for percent yield, it is the actual yield divided by the theoretical yield times 100%. So you need to know the difference between the actual and the theoretical yield. The theoretical yield is what you calculate. It's the maximum amount of product that you can get. So if your reaction is 100% efficient, the amount that you get is the theoretical yield. In actuality, you never get 100% yield. It could be 80%, 70%, it's never perfect. The actual amount that you get in a reaction, that's your actual yield. So the actual yield is usually given to you in a problem unless they want you to solve for it. And the actual yield usually is the grams of product. You see how we want to find the percent yield of CO2? That means that we need to use the actual yield of CO2 and the theoretical yield. They gave us the actual yield of CO2. They said, 70 grams of carbon dioxide was produced. That's how much we actually got in the experiment. So we know the actual yield. What we don't know is the theoretical yield, the most that we can get from the experiment. So let's calculate the theoretical yield, the maximum amount of CO2 that is possible to get. So we're going to start with the 30 grams of propane. We're going to see how many grams of CO2 can be produced at most from 30 grams of C3H8. So let's start with 30 grams of C3H8. The first step is to convert to moles using molar ratio. So the molar mass of C3H8, which we get from the periodic table, it's about 44 grams per 1 mole. Carbon has an atomic weight of 12, so 12 times 3 is 36. Hydrogen is about 1, and there's 8 of them, so 8 plus 36, you get 44. Now you want to do this in such a way that the grams of C3H8, they cancel. The next thing you want to do is you want to change the substance. You want to convert from moles of C3H8 to moles of CO2. Whenever you want to change from one substance to another substance, you need to use the molar ratio. And the molar ratio, it's a 1 to 3. For every 1 mole of C3H8 that burns in a reaction, 3 moles of CO2 are produced. And since we have moles of C3H8 on the top left, we need to put that on the bottom right so that they cancel. And therefore, the moles of CO2 will go on top. And then we simply add the numbers. There's a 1 in front of the C3H8, so we're going to put that here. And there's a 3 in front of the CO2, so we'll put that there as well. So moles of C3H8, they cancel now. The last step is to convert from moles back to grams. Whenever you convert from grams to moles or moles to grams, you need to use the molar mass in the periodic table, which is the same as the atomic mass. Carbon has an atomic mass of 12, oxygen is 16, and there's 2 of them, so that's 32 plus 12, that's 44. Now, because we have moles of CO2 on the top left, we need to put moles of CO2 on the bottom right. We want those units to cancel. So therefore, grams of CO2 has to go on top. And we said the molar mass of CO2 is 44. So that means that there's 44 grams of CO2 per 1 mole. So now we can do the calculation. So the numbers on top you multiply and you divide by the numbers on the bottom. So 30 divided by 44 times 3 times 44. So this gives us a theoretical yield of 90 grams. So what this means is that if all of the 30 grams of C3H8, if all of that reacts, the most that we can get, the maximum amount of CO2 that can be produced in this reaction is 90 grams of CO2. So that's what the theoretical yield means, the maximum amount that you can get. Well, in this reaction, we only got 70. So now that we have the theoretical yield, we can find the percent yield. So the percent yield is going to be 70 divided by 90, is always the smaller number divided by the large number, times 100%. And that is going to equal 77.7% or 77.8%. So that's the percent yield of this reaction. That's how you find it. So that's it. That's all I got for you today.